Woohoo! We are live. This is Math 60 Intermediate Algebra, and this is section 2.4, and we are going to write equations of lines. So in the last few sections, we've been talking about graphing in general, and now we're talking about linear equations. And now in this section, we're going to go over some very basic forms. Answer the question, what does the equation of a line look like? So we know what the graph of a line looks like, but how do we actually describe that in a consistent sense? So can we memorize these forms? Can we codify these forms? So the first form, which is called the standard form, and it will be useful later on, but right now it's going to feel like the totally useless form. So standard form, ax plus by. So the x and the y are over on the left. Notice I've got capital A, capital B, capital C, so you know something important is happening. This is how lines fit into the bigger category of equations, which if you continue on with algebra, you will study. But for right now, all we're going to do is we're going to say, well, if I get one in this form, notice that B and A and C could all be positive or negative. So I got 3x minus 4y equals 12. So here A is 3, B is this negative 4, and C is 12. So x and y on one side, number on the other side. And what I'm going to do is I'm going to say, yeah, this is interesting, but not really the most useful form for us. So I'm going to go ahead and solve for y. So I got 3x minus 4y equals 12. I want to solve for y. There's y right there. I'm happy to leave y on the left. Even though it's negative, it's not going to be terrible. We can handle this. So I'm going to go ahead and subtract 3x from both sides. Remember, and I know this is going to seem perhaps a little too rudimentary for some, but I'll just remind you that when you put your pen or pencil down on the equal sign, like that, you should have a minus 3x on each side. They should not be both on one side or the other side. They should be on either side. Okay, so that cancels the x's, and I've got negative 4y equals, and I'm going to make a choice. And my choice is that I'm going to write the x's first. Since these are not like terms, I can't combine them. They have to stay separate. I'm going to write the x first and then the constant. And this is because I know what's coming on the next page. Next step, I want to isolate the y. So I'm going to look at this. Now, this is a minus 4. So your brain is probably thinking, oh, I should add 4. But in fact, what you need to remember is that I've got negative 4 times y. So to get these two separate, they're a little codependent, to be honest. Let's separate them out. Let's get y living on their own, seeing what life is like when they live for themselves. So not that negative 4 was a bad number, just that maybe it needs a little time. They each need a little time to remember who they were individually. So we're going to get y by itself. We're going to isolate it. So I'm going to divide everybody by negative 4. And by everybody, I mean everybody. Everybody gets a negative 4. So there's a negative 4 here. There's a negative 4 here, and there's a negative 4 here because there were 1, 2, 3 terms. So negative 4 3 times. Of course, in the first case, the negative 4 cancels, and you've just got the y. Then here I've got negative 3x over negative 4. I'm going to have to clean that up in the next step. And then here I've got 12 over negative 4. So what remains is that I need to reduce a bit. Simplify. If I've got a minus on top and a minus on the bottom, it becomes a plus. So this is actually 3x over 4 or 3/4 x, depending on how you like to write it. Now, if there's one minus sign, that becomes the dominant sign. And I've got 12 over 4, which reduces to 3. So I have solved for y, and I've isolated it. Woohoo! So now let's look. I know you guys are like, wait, what's on the next page? What is so exciting? So what's on the next page is that if we start with standard form, let me scooch this in so you can see both of these. Scooch, scooch. Okay, so here's standard form. And now we've got what a lot of people call the mx plus b form, which is fine. Pardon me. It's actually called the slope-intercept form. Those of you going on in math, you really do want to memorize these forms. They're going to become important in your next math class and then after that. But in solving for y, I automatically have it in this form. And look at me anticipating that we were going to get to this place. So if we've got y equals 3/4 x minus 3. See how that is really 3x over 4 is 3/4 x. Slightly different way to write it, but same basic idea. Okay, so let's look at what happens now. We took it from standard form. We solved for y. Now we've got slope-intercept form. And I'm going to tell you something amazing. Spider's here to witness how amazing this is. Spider's very excited. So what's so amazing? Well, when you solve for y, this number that's right next to x is the slope. Remember, that's the slope. So the slope is 3/4. And this is the b, which is the y-intercept. So that means that this corresponds with the point 0, -3. Now, what is the benefit of this? Well, if you know what the intercept is, you know where to start it, and you know what the slope is, and I'll remind you about slope. Remember those triangles. If you know you're starting at 0, -3, and the slope, remember, is the rise over the run. So that means if we go over 4 and we go up slightly less, we go up 3, because this is positive. There's the next point. So we could graph the whole line using just the y-intercept and the slope. So we could just jut out the graph really fast that way. So this is a miraculous thing to be able to get to. So let's practice a bit. So next problem, write an equation of the line passing through 0, 4 with the slope equal to -5. So what does that mean? Well, and again, notice I'm doing this without a grid, just to do a little sketch. If I have a point and I have a direction, the slope is -5. So that means it goes down, and it goes down pretty steeply. If I have a starting point and I have a direction, do you agree that I have a line? Yeah, I think I have a line. I think I know what the line looks like. So I should be able to come up with an equation. And that's why I've got some interesting words here. I'm asking for an equation because there are many equations for each line, but it's the line. So there's one line, and I want you to pick one equation. Well, if I have 0, 4, because x equals 0, that means I have the y-intercept. So what is b in the y equals mx plus b? B is the y value. It's the 4. And the slope equals m is -5. So my equation, mx plus b, and notice how I am sneakily, if you're copying down notes with me, I'm getting you to write all the formulas a bunch. Y equals -5x plus 4. It's that easy. No fuss, no muss. You've just got an equation. Bam. So if you do happen to know the y-intercept and you do happen to know the slope, you've got an equation. And remember, this is called slope-intercept form. Okay, so let's see what's coming. This is exciting. We've got another form. Now, this form tends to be, lately, it is not being taught as much in high school. I know in high school, the slope-intercept is getting all the attention, and point slope is like, oh, by the way, there's this other one. This is a brilliant, beautiful form. It comes from the definition of the slope, and it says y minus y sub 1 equals m times the quantity x minus x sub 1. And I know when we bring in the the subscript, everyone, their eyes start spinning around and people are like, oh no, what do I do? And the answer is, don't panic. Don't panic. This is going to be our all-purpose form. Let's go back to the other form. To use the slope-intercept form, I have to know the slope, which I don't know yet, and I have to have a y-intercept when x equals 0. So that's got to be 0 and then some number. Do I have a 0? No. So this form is beautiful if you have the privilege of a lot of information. But if you just know 2 pieces of random information, I know 2 points. Now, if I tell you where the 2 points are, do you know where the graph is? Or do you know where the line is, I should say? Yes, absolutely. 2 points determine the line. Absolutely. So how do we go about it? Well, if you get 2 points, there are no intercepts, no y-intercept given. There's probably a y-intercept, but there's no y-intercept given. So first, start with the slope. The slope, which is the rise over the run. And here I'm going to use the formula, y2 minus y1 over x2 minus x1. You could also take a grid and graph these and look at the triangle, right? You could also say, I've got, let's see, 1, 8 is like here and 3, 4 is like here. So here's my line. This is just a sketch, but I could do my walking over and then my walking down, and I could find the slope that way as well. So I can use triangles to find the slope, or I can just use my handy dandy formula. So here I have to pick one of the 2 lines to start with. I'm going to call 3, 4 my yellow, and I'm going to let 1, 8 be my blue. So I'm going to, because the 8 is bigger than 4, you get to pick whichever one you want. I'm going to start with 8 and subtract 4. So here's the blue y, and I'm subtracting the yellow y on top. And then down below, I have to start with the same point. If I start with the blue one on top, I have to start with the blue one on the bottom, 1. And then I'm going to subtract the 3. So here are the y's. The rise are the y's. There you go. So here are the y's. Here are the x's. And here's the blue x and the yellow x. And you see they line up. So here's 3, 4. There's 3 and 4. 1, 8. There's 1 and 8. They have to line up like that. Okay, 8 minus 4 is 4. 1 minus 3 is -2. And 4 over -2 is a -2. Now, if you had done the triangles, I will tell you that what you would get is you would get 2 going this direction, and you would have it heading down 4, so like -4 in a vector form. So you would have gotten the same values, the rise over the run, -4 over 2 equals -2. So if you had done counting wise on a graph, you would have gotten that as well. Okay, we have our slope. Yay! Slope equals -2. Next, pick one of the points. If you're given more than 1 point, you get to pick one. It does not matter which one you pick. You will get the same result from each of them. You just look at whichever one is more friendly. And I'm going to go with the yellow one because it's first. I'm picking 3, 4. I recommend that when you're watching the video, pause it now, try picking 1, 8 and see if you get the same result I do. That's what we would do in class. We would do 2 different problems and see if we all end up in the same spot. So pick one of the points, 3, 4, and let's use the formula. The trick to the formula is to know that the subscripts are the numbers. And the variables don't have subscripts. So what does that mean? Well, when I use this formula, I get y minus, and here's my 4, and then equals, slope is -2, x minus, and then 3. Now, some people are going to look at this and go, oh, well, x1 and y1 are because 3 and 4 were your x1 and y1 here. Yes, but you could use 1 and 8 here just as easily. Okay, so this is an equation. And if someone asks you what's an equation of the line, you can stop here. But if they say, nah, I want it in slope-intercept form, which is very common, this is in point slope. Then what we would do is if you are asked for slope-intercept form, then solve for y. So I need to get a piece of paper because I've run out of room. I write so nice and big. So I'm going to do this. This will be y minus 4 equals negative 2 times the quantity x minus 3. And we want to find it in slope-intercept form. So how am I going to do that? Well, there are a couple steps involved. You can do different orders. I'm going to go ahead and use the distributive property, multiply out. Y minus 4 equals negative 2x. Notice I've got the two minuses coming together. Do I have my Bat brothers? Oh no, one of the Bat brothers seems to be sick. Or maybe on the floor. Well, I will do it with the Bat brothers. I will be the other missing brother. Oh no. So two minuses, make a plus. Okay, there we go. So this is going to be plus 6. 2 times 3 is 6. I'm going to add 4 to both sides. And this is that same equation, same line in slope-intercept form. So same line, slightly different way of looking at it. This is point slope. This is slope-intercept. So what does this tell us? Well, it tells us that we also know, we knew before, the slope was negative 2, but we also know from this being a 10, we know that the point 0, 10 is on the graph. So this gives us slightly different information. So there you go. If you are asked to find an equation, that could be sufficient. Or if they say, nah, put it in slope-intercept form, then you solve for y. And then you give this answer. Let's see if I don't run over all of my little arrows. I'll put a box around this one too. Both of these describe the same line. They're just different forms. Woohoo! Okay, one more little fun thing to do. Write an equation of the line passing through the points 3, 4, and 3, negative 2 in point slope form, then simplify into slope-intercept form. Okay, so if we're doing exactly the same thing, we might be practicing, or there might be something really interesting going on. Okay, so this problem looks like all the others. And we look at the 2 points and we say, okay, we got 2 points. Great. And so first step is find the slope. And again, you can either use triangles or I'm going to use the formula. The slope, which is the rise over the run, which is y2 minus y1 all over x2 minus x1. And so I've got the 2 points. So you guys, if we were in class, I'd say, which one do you want to start with? I'm going to start with this one because it's positive. 4 minus a negative 2. And then x2 would be 3 minus 3. So I get 4 plus 2 all over. And then the world ends. Big explosions. Oh no. Oh no, this is undefined. Oh no, it's undefined. Ah, here comes the shark. Gonna eat me. Ah, yum, 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 yum. I have a lot of carnivores when I do math. For some reason, math and big teeth kind of go together. Nom, nom. So what just happened? Well, we've got an undefined slope. Does that mean that everything is broken? No, math is working perfectly fine. It just means that we don't have a way to describe what's going on from the perspective of slope. So what does that mean? When in doubt, graph. Now, I know it's going to sound weird, but more and more as you go along in algebra and then hopefully, trig, more algebra, calculus, all that fun stuff, more and more graphing is going to actually help you. So if you don't know what's happening in a situation, something weird comes out, let's take a picture. Let's try to draw a picture of this. Now, I'm not going to do a beautiful graph. I'm going to do a sketch. So I consider a sketch anytime you don't use a grid, because that means it's not going to be beautiful. It's going to be close. It'll be lovely, but it probably won't be perfect. 2, 3, 4, 5. So there's my 3 right there. 1, 2, 3, 4, 5. There's 4 right there. 1, 2. There's -2. I've drawn some of the interesting values. And so I've got the point 3, 4 right there. And then I've got the point 3, -2. And it might be dawning on you what's actually happening. This turns out to be a vertical line. And hopefully you remember from earlier in the chapter, you remember that vertical lines go by the name x equals, in this case, x is always 3. So we've got the vertical line x equals 3. Can I write it in point slope form? No. Can I write it in slope intercept form? No. This is the only form it has. So this is in the whole set of mathy things, this is kind of a trick question because you have been asked to do something that's impossible. Can you write an equation on the line? Yes. Can you put it into these forms? No. Does this happen sometimes? Yes. Is it annoying? Yes. Absolutely. But you know what's not annoying? You guys are brilliant, and we have finished chapter 2. So when you next see me, we will be in chapter 3. Woohoo! Happy dance, la la la. Okay. Remember, hydrate, get outside, get some exercise, and then do lots of homework. Woohoo! Math on, guys.